3i Atlas is now moving toward its closest point to Earth, and the strange thing is that the closer it gets, the more it breaks every prediction scientists made before. Images that once looked like signs of a breakup have now been completely overturned because new observations suggest the core might still be stable while the tail is fading in a way no one can fully explain. This contrast between what we expected and what is really happening has opened a much bigger mystery. In this video, you'll learn what witnesses reported, explore the details that have baffled UFO investigators, and understand why the Joshua Tree incident has become one of the most unexplained cases in years. Near-Earth object. Astronomical telescope is one of the main ground-based telescopes that watches objects moving close to Earth, and it is designed to capture clear images of fast-moving or unusual targets. It scans the sky every night to track changes in brightness, shape, and movement, which makes it especially useful for monitoring something as unpredictable as 3i Atlas. Because 3i Atlas is dim, strange, and surrounded by unstable dust, near-Earth object. Astronomical telescopes' repeated observations became one of the most important tools for studying it. The telescope finally received perfect viewing conditions this week because the sky was quieter and the surrounding dust thinned out. This allowed the system to capture the clearest frame of 3i Atlas ever recorded, giving researchers a chance to see details they had been waiting for. The new image showed the inner glow of the comet with a level of precision that earlier photos could not achieve. Scientists processed the frame and created a brightness map, hoping to understand if the nucleus had broken apart or stayed whole. The center of the map appeared smooth, round, and evenly lit, which is a pattern usually linked to a solid core. A broken object often shows stretched or uneven light, yet this model revealed a balanced structure that surprised many people. This unexpected stability forced astronomers to revisit the idea that the comet was collapsing, since the evidence now pointed in a different direction. Near-Earth object. Astronomical telescope also captured small texture changes in the surrounding glow, showing how dust drifted gently around the object. The flow looked calm and controlled, which suggested the comet was still active but not in a chaotic state. These gentle patterns helped explain why earlier images looked confusing, because small angles of sunlight can easily distort the appearance of a dusty object. The improvement in clarity gave experts a stronger baseline to judge the comet's health rather than relying on noisy or unclear photos. Some researchers noted that the stable center might indicate a thicker protective layer of dust, which could shield the nucleus from extreme heat. Others suggested that a circular brightness pattern usually means the main body is still structurally sound. This new frame became a major turning point because it offered the first high-quality evidence after weeks of speculation. The image spread quickly among astronomy communities because it challenged the dramatic predictions that had dominated earlier discussions. People were surprised to see that the inner glow remained intact despite the intense solar radiation from its close pass around the Sun. Near-Earth object. Astronomical telescopes' data also supported the idea that the comet's trajectory remained stable because the core had not fragmented. This raised new questions about what makes 3i Atlas stronger than other comets that usually break apart under similar conditions. The updated measurements encouraged more scientists to look deeper into the nature of this interstellar visitor. For many viewers, the Near-Earth Object Astronomical Telescope frame proved that the story was far from over because the object behaved in a way that did not match early fears. The clarity of the image brought a sense of order, yet it also added new layers of mystery that pushed the investigation further. The sharp images from Near-Earth Object Astronomical Telescope changed the direction of the story, but the next surprises came from people who were not using giant observatories at all. While scientists studied the new brightness map, amateur astronomers continued to watch 3I Atlas every night, giving them a special advantage that professional teams sometimes lack. They spent long hours tracking the object with portable telescopes and night vision cameras, building a steady timeline of how its glow shifted from one night to the next. This constant monitoring created a record that helped fill the gaps between large scientific observations, especially during moments when the object behaved unpredictably. One of the most talked about images came from an observer in Puerto Rico who captured the comet during a calm and clear night. His frame showed a faint curve in the tail, which immediately caught attention because the shape looked slightly twisted. This gentle bend mattered because dust from a rotating body often forms curved patterns as sunlight pushes the particles outward. The image suggested that 3I Atlas might be spinning slowly, and some people estimated that one full rotation could take around 16 hours. Although the picture was not as sharp as images from professional telescopes, it revealed a motion pattern that large observatories did not capture at that exact moment. Amateur observers often stack many frames taken across different nights, and this method makes tiny changes easier to detect. These long exposure techniques helped researchers understand how the dust cloud shifted and reacted to pressure from the solar wind. The Puerto Rico image also showed that the tail was weaker than it had been earlier in the month, supporting the idea that the object's activity level was dropping. A fading tail can happen for many natural reasons, including lower heat, slower gas release, or changes in surface material. Skywatchers shared this detail widely because it challenged the belief that the object was breaking apart, since a collapsing nucleus usually produces stronger bursts of dust. The fading pattern pointed to a calm and controlled process instead of a violent event, which raised new questions about what happened during the close pass near the Sun. Observers from other countries reported similar patterns, noting that the tail looked thinner on some nights and brighter on others. These variations were important because they showed how sensitive 3I Atlas was to small environmental changes. Some images captured faint jets drifting sideways, which seemed unusual at first, but later aligned with known behavior seen in other long-period comets. Amateur groups compared their images and noticed that the dust flow sometimes shifted direction slightly, hinting that sunlight angle played a larger role than expected. Their teamwork allowed them to build a timeline of changes across several weeks, becoming a valuable resource for scientists who needed continuous data. Many photos also showed hints of blue or green tones in the glow, suggesting that the dust might contain unusual materials. These colors were not clear enough to confirm the chemistry, yet they encouraged researchers to look deeper into the object's composition. The growing archive of amateur observations helped shape a fuller picture of 3I Atlas, especially during nights when major observatories had limited visibility. Each image added a small piece to the puzzle, revealing slow shifts that would be impossible to detect from a single snapshot. Their steady contributions provided important context for understanding how the comet's appearance changed from day to day. This mix of amateur and professional data now formed a clearer foundation for the next step in the investigation. But what do NASA's probes and major telescopes actually confirm about the true nature of 3I Atlas? NASA's official data gives us the strongest foundation for understanding 3I Atlas because it comes from instruments that collect measurements directly from space. The most important point is that NASA's probes confirm 3I Atlas behaves like a natural comet in several key ways, even though some parts of its appearance remain unusual. These missions include MAVEN, Hubble, JWST, Lucy, and Psyche, and each one provides a different piece of the puzzle. MAVEN detected a cloud of hydrogen surrounding the object, which happens when sunlight breaks apart water molecules released from the surface. This finding is important because hydrogen halos are a classic feature of natural comets that have enough ice to release gas when heated. JWST helped scientists study the chemistry of the dust by measuring the infrared light coming from the object. Its data showed an unusually high amount of carbon dioxide, which is different from most comets inside our solar system. This suggests the comet formed in a colder and more distant environment, possibly around another star with very different conditions. Hubble also played a major role by watching how the tail behaved as the comet moved away from the Sun. Its images showed no clear signs of the nucleus breaking apart because a fractured object normally leaves a trail of small fragments. Instead, Hubble recorded a smooth and steady glow that supported the idea of a single core releasing dust at a controlled pace. Meanwhile, the Lucy and Psyche missions measured changes in the comet's path as it traveled through the inner solar system. These probes confirmed that the object's trajectory remained stable even after intense solar heating, which would be unlikely if the nucleus had split into pieces. Their measurements allowed NASA to calculate the object's orbit with high accuracy, showing that it continued to move as one solid mass. Another important detail is the observation from HiRISE, which did not detect the nucleus directly because the dust cloud surrounding it was simply too thick. This situation is normal for comets that produce heavy dust, and it explains why some people believe the core had disappeared. The truth is that the nucleus is hidden behind a dense layer of material, and the camera could not penetrate the glow. This result brought more clarity, because it showed that the missing nucleus was not evidence of a breakup, but a limitation of the camera angle. All of these pieces of data help scientists form a clearer picture of what is happening inside the bright cloud of dust. They show that 3I Atlas is active in a natural way, that its chemistry is unusual but not impossible, and that its path matches the behavior of a real interstellar comet. NASA will release more updates as the object moves farther from the Sun, and these measurements will help researchers test new ideas about its structure. Each new report brings us closer to understanding whether the nucleus is stronger than expected or whether a deeper mystery is still waiting behind the dust. The official evidence paints a picture of a stable but unusual visitor, yet there are still unanswered questions about the strange behavior seen in earlier images. Some of the most confusing moments in the 3I Atlas story come from behaviors that do not fit neatly into the usual patterns of a comet. These observations are not signs of alien technology or hidden engines, but they show that this object acts differently from what scientists expected when it first entered the solar system. Many of these odd features were recorded on different nights, which makes the puzzle even harder because the comet changes depending on sunlight, dust pressure, and distance from the Sun. One of the earliest mysteries was the sideways jets that appeared in several amateur images and a few scientific frames. These jets looked like faint beams drifting to one side, and they gave the comet a slightly bent shape that confused viewers who expected a straight and simple glow. In normal comets, these jets usually release dust in predictable lines, but 3I Atlas sometimes fired them in unusual directions. This behavior created the idea that something inside the nucleus was shifting or that parts of the surface heated unevenly. Another odd feature was the moment the tail seemed to point toward the Sun instead of away from it, which created what people called a backward tail. A backward tail happens when dust gets pushed by different angles of solar wind, and although the effect is rare, it can appear when the comet rotates in a specific way. Viewers who saw this shape believed it meant the nucleus had changed direction, yet the effect was more likely caused by sunlight striking the dust cloud from the side. This strange appearance still made the comet look unstable because people are used to seeing tails always point away from the Sun. Color changes also appeared in several amateur photos, especially ones taken during long exposure sessions. Some nights showed hints of blue or green tones in the glow, which suggested that different materials were being lifted from the surface. Scientists explained that these colors often come from gas molecules reacting to light, and the appearance can shift depending on temperature and distance. Even with that explanation, the sudden changes in tone made 3I Atlas look unpredictable. There were also moments when the dust cloud appeared thicker than before, almost as if the comet had released more material during a short burst. Dust bursts can happen naturally when pockets of ice open under heat, and this process creates a temporary cloud that fades as the comet moves farther from the sun. These natural explanations were reasonable, yet the timing of each burst made it difficult to understand a clear pattern. Some nights produced almost no activity, while others showed new structures forming inside the glow. This inconsistency caused debates among researchers because the object never settled into a single behavior. Another confusing point came from the rotation rate, which many people believed to be around 16 hours, based on the curved shape of the tail. A slow rotation can explain the gradual bend, but scientists have not confirmed the speed because dust patterns shift in many ways. The rotation question became a major topic in astronomy groups because it could explain why the comet looks so different from one night to the next. These strange behaviors still fall inside the range of natural comet activity, but together they create a picture of an object that does not follow simple rules. Researchers continue to study these details because each odd moment might reveal something about how interstellar comets survive long trips between stars. The strange patterns also attract attention from people outside the scientific community, and some of them believe these behaviors mean something more unusual is happening inside the dust. The idea that 3I Atlas might be a form of alien technology did not appear out of nowhere because several unusual observations gave people reasons to wonder if something more advanced was hiding inside the dust. Some viewers were first drawn to the missing tail, since early images showed a long and bright streak that suddenly weakened after the comet passed the sun. A fading tail is normal for comets, yet many people believed the change looked too sharp, and they thought it meant the object stopped releasing dust. This led to online theories claiming the object had shifted into a controlled mode, as if it were adjusting its behavior like a machine. Others pointed to the fact that 3I Atlas showed sideways jets that looked strangely directional, and they took this as proof that the object was firing some kind of engine. Most scientists explain these jets through natural heating on the surface, but some viewers insisted the angles looked too precise to be random. A third reason came from the object's slight increase in speed as it moved away from the sun, which a few people interpreted as acceleration caused by a hidden system. This claim spread quickly online because the idea of a comet speeding up without a clear cause sounded mysterious. Experts explained that the speed change was small and caused by natural outgassing because material leaving the surface can act like a tiny push. However, these explanations did not stop people from connecting the change to science fiction ideas about spacecraft propulsion. Another major factor came from a misunderstanding about high-resolution imaging science experiment, images that NASA had not released during the government shutdown. Some people believed the delay meant the agency was hiding proof of an artificial structure, and this rumor grew quickly on social media. In reality, the delay had nothing to do with secrecy, yet the timing made the situation look more mysterious than it really was. A few online videos also focused on the high nickel levels reported by early observations, and they claimed this metal was evidence of engineered material. Scientists disagree with this completely, because nickel can appear naturally in very old comets, especially ones that formed in extreme environments. Even so, the metal detail became a favorite point for people trying to argue that 3I Atlas was not a natural object. Another source of speculation came from the idea that the comet might be 7 billion years old, which some people believed was too old to stay intact on its own. They argued that a machine could last longer than a natural object, but this idea had no scientific support. Popular influencers added even more fuel by posting animations showing the comet revving up or changing direction, and the dramatic visuals made the theories look believable. The combination of strange colors, unexpected dust patterns, and dramatic online commentary made the object feel like something alive. This atmosphere created a perfect space for alien theories to grow, because people were already excited about the idea of an interstellar visitor. Some theories even suggested the object might be a probe from a distant civilization, designed to study planets by passing through their systems. These ideas sound exciting, yet none of them match the data collected by NASA or the major telescopes that study the object scientifically. Scientists continue to emphasize that the unusual parts of 3I Atlas still fall into the range of natural behavior, even if those behaviors are rare. The mystery continues mostly because the comet comes from another star system, and anything that old and distant will naturally look unfamiliar to us. All these mixed signals created a story filled with imagination, fear, and curiosity, and the debate still grows as the comet moves through the inner solar system. And this brings us to another question that shaped the entire discussion. If so many unusual theories appeared, then why did so many people once believe that 3I Atlas had completely broken apart? The belief that 3I Atlas had shattered grew quickly because many early images made the object look unstable and damaged. The first confusion came from the tail, which became much weaker as the comet moved away from the Sun after its closest pass. A fading tail is normal for natural comets, yet the speed of the change looked dramatic enough for many viewers to assume something had gone wrong near the Sun. Some early frames showed the tail stretched into thin strands, and the uneven glow created the illusion that the structure had broken. These effects were caused by strong solar wind, which can pull dust into separate layers and make the shape appear distorted. Because most people only saw single images instead of a full sequence, they never saw how the dust slowly returned to a calmer pattern. Another major source of confusion came from Earth's viewing angle, which changed just as 3I Atlas entered a more active stage. Sunlight hit the dust cloud from different directions each night, making the glow look wider or narrower depending on the observer's position. This shift made the hidden nucleus appear stretched, even though the real core was concealed behind a dense cloud of dust. Some amateur photos even showed two bright spots, and this led to a rumor that the comet had split into two parts. Scientists later explained these spots were reflections from long exposures and unrelated to the nucleus. Still, the dramatic idea of a broken interstellar comet spread quickly online. More confusion appeared when the dust cloud changed shape suddenly over a few hours, which some observers interpreted as the moment the core collapsed. In reality, dust clouds often shift rapidly when pockets of ice open under heat and release fresh material. This natural behavior can easily look like destruction when viewed without context. Another common argument for the breakup theory came from comparisons to comet YSON, which disintegrated under extreme solar heat. Many people assumed 3I Atlas faced the same fate, even though the two objects had different structures and different dust layers. Experts warned that comparing them too closely could lead to wrong conclusions. The lack of a visible nucleus in early high-rise images also caused confusion, leading some to believe the core had vanished. NASA later confirmed that the dust cloud was simply too thick for the camera to penetrate, meaning the nucleus was hidden, not gone. By the time this clarification arrived, the breakup theory had already spread widely across social media. As more data came in from larger telescopes, scientists showed no evidence of fragments, and the story slowly shifted back toward a stable nucleus. These corrections helped calm the discussion, but the situation revealed how quickly a mystery can grow when images look strange and information spreads unevenly. And this leads to the final question that defines the entire story. If 3I Atlas truly remains whole, then what larger meaning does this interstellar visitor hold for our understanding of the universe? 3I Atlas matters because it carries material from far beyond our solar system, and this makes it one of the rarest objects humans have ever studied. Scientists believe its chemistry reflects conditions around another star, since its high carbon dioxide levels and unusual metals do not match the comets formed near the Sun. This difference shows that planetary systems can create very different types of ice, dust, and minerals depending on where they were born. If the nucleus truly remains whole after passing close to the Sun, then 3I Atlas proves that some interstellar objects are much stronger than we once imagined. A stable core surviving that level of heat gives researchers a chance to study ancient material that may be billions of years older than the planets around us. This information could help scientists understand how early stars formed, how dust moved through young galaxies, and how solid bodies survived long journeys between star systems. Every measurement we gather from this visitor becomes a clue about the distant regions of the universe that we cannot reach with spacecraft. Its presence reminds us that our solar system is not isolated, and the space between stars carries travelers that hold secrets from far away. 3I Atlas has turned into one of the most surprising interstellar mysteries of our time, because every new image overturns what we thought we knew. The nucleus might still be whole, the chemistry looks older than our solar system, and the dust keeps behaving in ways no one expected. But the real moment is coming soon. In the next few weeks, NASA will release new data from James Webb Space Telescope, SOHO, Lucy, and Psyche, and these updates could completely rewrite the story. They might confirm the comet's true structure or expose something we have never seen before. Please follow videos from MindGap to update the latest information about 3I Atlas.